All right, as you set up to solve this, do you need to sketch out the entire 22-sided regular polygon? No. But it's a good idea to have a sketch of something. What can you use as a reference here? If you just take the isosceles triangle that you use as a reference, how many of these isosceles triangle will rotate about this vertex? You'll have a total of one for each side, right? So 22 of them. Okay, so if you just imagine that this is the isosceles triangle that's used as a reference, okay, of this we know the length of its base. It's the length of each side, or 12. And then we know the area formula for a regular polygon. Area is equal to 1/2 SAN. And so in this formula, we know the length of the side, 12. We don't know the apothem yet. That's what we're going to be looking for. And we know the number of sides. It's a 22-sided polygon. So all we need to do is find the apothem, this measure A. So when we're looking for A, we have this right triangle now. That's our reference from the isosceles triangle. Okay. And so what does this altitude or the apothem do to the base of this isosceles triangle? Bisects it. So this length is going to be 6. And so now in order for us to find A, we need to either identify this angle or this angle. I'm going to show you each case, and you only need to pick one though. Probably the easiest calculation though will be to find this angle here. And to find that angle, we're first going to find the vertex angle of the entire isosceles triangle. So how would we find that whole angle measure? How many of these triangles did we say are rotated about here? Aaron? Yeah. Good. So if we take 360 and divide that by 22, that's going to tell us what each angle is. So each of these vertex angles is 16.36 continuing. And so when we look at that, what fraction of that whole vertex angle is the reference angle in this blue right triangle? It's half of that. So if we divide this in half, we get an angle of 8.18 continuing. So this is the measure of our angle here. And that's enough information to solve. We have a right triangle with an angle measure, a side opposite that angle, and a side adjacent to that angle, which trig ratio relates opposite and adjacent. Tangent, so we can set up our trig ratio. The tangent of 8.18 is equal to opposite 6 over adjacent A. And now we can solve this equation. To solve it, you'd multiply both sides by A to get rid of your fraction. Isolate your variable A by dividing both sides now by the tangent of 8.18. So that isolates your A. And so if you take 6 divided by the tangent of this angle measure, which we can highlight here, select the entire answer, don't approximate it yet. And hit enter and you get your apothem, 41.73 approximately. All right, so if we take this number that we just got for the apothem, multiply that by 22, and then multiply that by half of 12, you get, there you go, 5,508.48 square centimeters, because you're dealing with two-dimensional measurement of area. Okay, so there's your total area. Now, what if you wanted to find this base angle instead? Okay, so if instead of finding this angle, we wanted to find this base angle, you'd still wind up doing a similar process. So here, what you would need as a reference would be to maybe sketch out a couple other interior angles. The easiest way to find what this interior angle is would be to extend it, find what the exterior angle. The exterior angle is going to be 360 divided by 22. Again, it's the same answer that we got up here, right? 16.36 continuing. And so to identify what each interior angle is going to be, we'd take its supplement, 180 minus that quantity. And so each interior angle is going to be 163.63. And so how would we find this base angle from that? Divide by 2. And so this base angle would be 81.81. which is consistent with the other angle being 8.18. We could have just found that complement. Okay, and now if we have this angle, we have a side opposite and a side adjacent. We're still dealing with a tangent ratio, but this time the tangent of 81.81 continuing is equal to opposite A over adjacent 6. Now, the advantage to doing it this way, okay, there's an advantage and disadvantage for each way. This way gives you an easier tangent or an easier calculation at this level because all you have to do now is multiply by 6. And so if we can take our tangent of this angle and multiply it by 6, and that'll give us our apothem with an easier calculation. And now the advantage of the disadvantage to this way is it's a little bit harder to find the base angle because you have to find exterior angle, find its supplement, take that supplement, divide it in half, and that gives you this angle measure. Okay, the advantage to doing it the top way is it's probably easier to find this original angle. Just take 360 divided by the number of sides and then divide that in half once more, and that gives you this angle. The negative to that method is it's a little bit tougher calculation in solving for the tangent.